All right, objective 20, just want to review a couple things and then we'll get into level 2s in this first video. So to review, we're going to find the area and perimeter of triangles. Remember that when you're finding area of a triangle, you always want to look for those right angles, okay? That's going to tell you what the base and the height are. If you can't find the right angle, don't just guess and say the base and the height or something. Okay, you got to look for that right angle. You got to be able to see that. Okay, so number one, perimeter of the first one. Let's take a look here. So perimeter, we need to know all four sides. A triangle is four sides. All three sides of a triangle. So if I only have two and it's a right triangle, I'm going to go ahead and do the Pythagorean theorem to find that third side. So I'm going to take 4 squared plus 6 squared, and that's going to equal c squared. So I have 16 plus 36, and this is going to be 52. Now I don't want to have a decimal, so I'm going to go ahead and square root both sides, and I'm going to simplify. This is 4 and 13, so this is going to be 2 root 13 for that third side. So if I add my perimeter all together, I'll have 6 plus 4 plus 2 root 13 for a final answer of 10 plus 2 square root 13. Because remember, you can't have, you can't add a square root when it doesn't have like roots. And I just wrote that in the area box, and that's not the area. The perimeter is 2 root 13. Okay, now let's go ahead and find the area. Again, area is where the two sides make a right angle. So if we look back up at the picture and we see the 4 and the 6 are the ones that make the right angle. So those are the ones that are the base and the height. So a couple ways that you can think about the area. You can think about it as 1/2 base times height, or base times height divided by 2. So 4 times 6 divided by 2 will equal 12, and I don't think it says any units. Oh, it does say centimeters. So we'll have centimeters squared for area and centimeters for perimeter. All right, let's take a look at the next one. This one's a little tricky because the height in this one is going to fall outside of the triangle ABC. So I want to find the perimeter of ABC, so I'm going to go ahead and outline that so I know what sides I'm going to add up, because there's a bunch of different sides going on in here. So those sides that I highlighted in red were 8.5 plus 5 plus 4. Okay, I'm going to ignore the other 4 and the 3 on the outside because that's not part of the triangle's perimeter. So this is going to be about 17.5, and the units is centimeters. Okay, so now the next one is area. So we talked about the base and the height, finding that perpendicular line, knowing what the base and the height are because of that. Well, like we just highlighted the triangle that we're looking for, ABC in red, the base here is BC, and the height, the thing that's perpendicular, the 5 is not perpendicular, that makes an obtuse angle. Here's the perpendicular. That perpendicular is 3 centimeters. So while the base is only 4 and it stops at C, the base does not go all the way to D, okay? The height in this case just happens to fall outside the triangle, and that's going to happen when you have obtuse triangles. But the base is just 4, it's not 8, okay? It doesn't go all the way to the height in this case. The height is 3, and we're still going to divide it by 2 to get us 6 centimeters. Okay, so sometimes the height is going to fall outside the triangle, that's fine. Just make sure that you know what the base of the triangle is and don't extend that to the height if it is outside the triangle. Okay, last one here. Now we've got it on a coordinate grid. Same idea here that what we want to do. Perimeter is going to be the distance around, so I can count this bottom one. This is going to be 1, 2, 3, 4, 5, 6, 7. And then these side ones, I cannot find those side ones by counting, so I'm going to have to use the distance formula to do that. So go ahead and pause the video, do the distance formula from point to point. This one's at -3, -1, 2, 3, 4. And this one is at 1, 5, and this one is at 4, -4. So go ahead and do the distance formula, pause the video, and then make sure that you got the right distances. Make sure you simplify your radicals too. Okay, so now we've got the distances of one leg to be the square root of 97, The other was a square root of 90, which we can reduce to 3 root 10. And then that bottom one was 7. So our perimeter, we can't add the two roots together because they don't have the same root underneath it. So what we're going to do is we're just going to write the square root of 97 plus 3 square root 10 plus 7 as our perimeter. Okay, and if there's no units, we'll just write units. Okay, now area, again, I don't really have the height drawn in, but I'm going to draw the height from the highest point to the lowest point here. And again, this is nice because I can just count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that height is 9, and the base we already know is 7. So if I go find my area, it'll be 1/2 the base, which is 7, times the height, which is 9. So 7 times 9 is 63, and you divide it by 2, and that will be 31.5 units squared. Okay, so just a little review for you as we get into more complex ones in level 2s. Okay, so now what we're going to do is we're going to find the perimeter of some composite figures and then area of a composite figure. So taking a look at this first one here, to find the perimeter, we need to know all these side lengths. So this one, this one, this one, and all the way around. Okay, the problem with this is that I don't have all of them right away. So I'm going to just look at the ones that I don't have, and I highlight those so I know what I'm specifically looking for. Okay, these are important. These come up on the ACT a lot. Okay, so I need to know this line here, this line. Actually, I'm going to make the horizontal ones different. Okay, and this one, and this one. Okay, so now we can assume right angles here. So now that I have a couple lines drawn in, I'm going to start by looking for some squares and rectangles. So I'm going to go ahead and just draw a line down here and kind of cut off those two rectangles. So if I look at this rectangle in here, I see that this line down at the bottom is 5, so I know that red line is 5. So I'm good there, so I don't need to find this one anymore. Okay. I still need to find these other two red ones, both on the bottom and then on the top. And here's what I like to look for. If I know that this line down here is going to consist of this plus this line, okay, and you can almost think about bringing this line down to meet this other one that we just drew in. Together, both of those lines are going to equal 18. So I don't necessarily need to know exactly what those are, but I do need to know that together they're going to equal 18. So what I'm going to do is I'm going to just label those two lines X and Y. So I know that X plus Y is going to equal 18. Okay, so again, I don't need to know specifically what those are individually. All I need to know is that together they equal 18. All right, the next thing that I need to know, so again, I already got those. Okay, so I'm going to erase those. I don't need to know them anymore. Okay, I'm going to leave X and Y because I need to remember that I need to add in 18. And then the other ones, I need to know the blue lines. Well, the blue lines kind of work the same way here. So if I draw lines going all the way across this way, and I bring the blue line here over this way, and this one over this way, and this one over this way, and this one over this way, I see that all of them are going to equal 16. So that, again, each individual one I don't need to know, but I do need to know that all of them together are going to equal 16. So just for the sake of labeling, I'm just going to say A, B, C, and D. So that A plus B plus C plus D are going to equal 16. Sorry. And, okay, so now what I'm going to do is I'm just going to add all the sides up. I figured out every single side length. Okay, I got this one, I got that one, I got that one, and I've got this one. So nothing is highlighted anymore. I've got them all done. So I'm going to add all of them up. So I've got 16 on the side here, plus 18 on the bottom. And now I'm going to add the D plus C plus B plus A, and I know that's 16 altogether. And then now I'm going to add the x plus y, and that's going to be 18. And then the last two that I got to remember to add in are these 5s. So I'm going to add in plus 10. So if I add all those together, 16 plus 18 plus 16 plus 18 plus 10, that's going to equal 78. So our perimeter is 78 units. Okay, let's take a look at an area of composite. So here we've got a couple different shapes right off the bat that I can see. I've got this curved line over here that tells me that I'm going to have some sort of circle, and it looks to be a semicircle because it's not the whole thing. Okay, and I know to find a circle, that's going to be pi r squared. But if it's a semicircle, I'm going to divide it by 2. And then if I see kind of like a triangle going on over here, and make that a right angle, I know that the area of a triangle is going to be base times height divided by 2. And then I've got this rectangle here. So this is length times width. Okay, so from here, I'm just going to find all the little parts. The rectangle is pretty simple. It's going to just be 6 times 12, and that's going to be 72. Okay, and now let's talk about the circle or semicircle on the other side. So since I've got a rectangle here, if this side is 6 on the left, it's going to be 6 on the right. So that length of the rectangle or width of the rectangle is 6, but that's also the diameter of the semicircle. So that means if the diameter is 6, the radius is 3. So if I find the area of the semicircle, it's going to be pi times 3 squared divided by 2, or 4.5 pi. So that's my area of the semicircle. And then last but not least is the triangle. So again, you're looking for this right angle in here to find the base and the height. Okay, I don't have the base. I don't have one of the dimensions, but it is a right triangle, so I can use Pythagorean theorem. And when I do the Pythagorean theorem, that side is going to be 3. So I'm going to do 3 times 4 and divided by 2, and that's going to be 6. So the last thing is just to add them all up. So 72 plus 6 plus 4.5 pi, and I want it in exact, so I'm not going to multiply pi into my answer, and I'm just going to add 72 plus 6 to be 78, and just leave it as 4.5 pi centimeters squared. So those are level 2s. Good luck.